All right, so good morning, student. We meet again. This time I will do a question on total internal reflection. This question is from the Cbse sample question paper. Very interesting question and a very nice question to understand the total internal reflection and how the change in refractive index impacts it. So let's start doing this question now. And I will start the whiteboard and watch me very carefully. Before I start, don't forget to subscribe to this channel. This is the only channel in the country which is giving explanation. I'm not solving questions, right? They are available on websites, but nobody explains you why you did whatever you did, right? So the whole focus of the conversation is to make you understand the concept so that you can retain it and you never forget it. So I hope you will like this video immensely. And let me start the whiteboard and then we can start working on this question. All right. So there you go. All right. So we have this question from the Cbse website, Cbse Academics, and I will now read the question for you and then we will solve it together. Okay. So there is a light ray entering a right angle prism, okay, undergoes a refraction at the face AC in the figure. What is the refractive index of the material in the figure 1? Okay, so if you notice, this question has a prism, and what's very, very striking in this question to me, what I found is this, okay, that the ray comes straight. So any ray which is perpendicular, okay, any ray which is perpendicular like this, okay, will go straight. If you have a face of the prism and the ray goes perpendicular, there is no refraction. It goes straight. Okay. So the ray has gone straight and now it has struck the surface AC, right? So this is where it has struck. This is where it has struck. And then what has happened? It has grazed through this surface. Grazed means along the surface which is touching the air. So you have air here, right? I hope this is making sense, right? You have to find the refractive index of the material. The given information is this is 45 degrees. Obviously, whenever I see that the ray has gone refraction of some kind, I want to apply Snell's law. But when I see the grazing, which means the ray comes in straight like this, okay? But instead of going out, the ray grazes. What does grazing mean? Okay, very important. So the ray grazes, right, like this, along the surface. This is a situation of critical angle. So the first thing that should strike you is that critical angle is to be found out. If you notice, in a lot of total internal reflection questions, you also need to know good geometry. Okay. Now, this is 45 degrees. Why? Because it's a right angle triangle. This is 45, 45, right? So how much is this angle? This is also 45 degree. I have always to draw a normal on the surface. So this is my normal on the surface, right? So my incident ray, which is coming, which is this, okay, which is already given in the question, strikes at some point and grazes along the surface. And therefore, my angle of incidence, which I need to measure, is this angle, right? So this is the angle I need to worry about because this is my normal and this is my incident ray. The angle between the incident ray and the normal is the most important angle I need to worry about. Now I know this is 45 degree. This and all is 90 degree. This is also 90 degrees. So the balance angle here is 45 degree. So my angle of incidence, okay, in this figure is 45 degree. All of this came from 45 degree knowledge. Okay, 45 degree, this became 45 degree, and then this became 45 degree, and then this became 45 degree. So I know my angle of incidence to be 45 degree. What is my angle of refraction? 90 degree. Okay. So what is a refractive index from Snell's law? Mu is equal to sine I by sine R. But we are talking about an angle of refraction to be 90 degree. You can see the angle of refraction here. Very simple, right? The refracted ray is like this. Your normal is like this. So your angle of refraction is 90 degree. So mu is equal to sine of 45 degree divided by sine of R, which is 90 degree, right? This is the general formula you use. But in this formula, remember, what is the value of mu? If you consider a normal prism like this, the ray of light is entering and getting refracted. So the refractive index is of the medium in which you're entering, right? So which medium am I entering here? Air, right? So refractive index of air with respect to what? The glass. So therefore, 1 upon mu of the glass is equal to sine of 45 degree. So what will happen? Mu is equal to root 2. I hope you were able to understand this, that which medium are we entering. And therefore, the way to write this was mu of air with respect to glass. Generally, whenever you do total internal reflection or refractive index questions like this, right? So you have your normal here and this is your refracted. The refractive index of glass with respect to air is written as sine I by sine R. So I is inside the first medium and R is inside the second medium. Similarly, in our question, what is the angle of incidence? It is inside the medium. And therefore, we will write the medium as air. Mu, the medium in which you are present. Your incident ray is present here, right? And your refracted ray is present in air in our question. In this case, the refracted ray is present where? It is present in the glass. And where is it coming from? Air. But in our case, where is the ray coming from? Medium going to air. And therefore, we have to write 1 upon mu glass, right? So, mu air glass can be written as 1 upon mu glass air. And therefore, if we solve this, what we get is mu is equal to root 2. So because this is 1 by mu is equal to 1 by root 2 and therefore mu is equal to root 2. So you have found the refractive index of the material of the prism in the above question. Okay, so I'm writing it in on the second part, but this is the part we have solved. I hope the ray diagram is very clear in your mind. If it is not, see it very carefully. I will just rub it, okay, so that you can see what exactly is happening in this ray diagram. Very, very important. So this was 45 degrees. I hope you already know this. This is 90 degree. This is 45 degree. This is the normal. This is 90 degree. So this is also 45 degree. So your incident ray and the normal are making an angle of 45 degree. And this is your angle of refraction, which is 90 degree. So sine of 45 degree, which is the rays coming from here to sine of 90 is equal to mu of air with respect to glass, because you are inside the glass medium. Okay, and this is what I wrote as 1 upon mu glass air. So I hope this made sense to you. A lot of geometry and detailed explanation for you. See it very clearly and you can see other questions also, which will give you some more knowledge of basic concepts of total internal reflection. Let's go to the question number 2. All right, so the part 1 was completely focused on the total internal reflection from denser to rarer. some knowledge of geometry, and you could get some angles and find the refractive index. We have found the refractive index now. What we're going to do now in the part 2 is change the medium outside the prism. The same prism, we will change the medium, and we have to decide, because of the change in medium, are we going to see total internal reflection? Are we going to see refraction? Are we still going to see grazing? So what I will do now is I will bring up the part 2 of this video. See it very carefully, because now what are we trying to do? We are changing the medium outside, right? And we have to decide whether the same ray which was coming in part 1, whether it gets totally internally reflected, or does it get refracted, or does it get grazed? So let me just bring that question up and let's see. Okay. So it's coming up. All right. So we can see the question number 2, right? That's our part number 2. I'll just rub this off so that you can read it very carefully. So this is what has happened in this question. Your medium has undergone a change. Okay. So your medium this is your new medium. See, the first thing, the logic is, if the total internal reflection has to happen or not is dependent on what factor? The critical angle, right? Critical angle, right? So the critical angle, let's see if we can find the critical angle. So the refractive index now has undergone a change. The refractive index of the medium in which you're entering, which is you may be refracting, the medium 2 is 2 by root 3. You can see, right? You've kept a liquid. And the first medium, which is your first medium, is mu1. And in this medium, your refractive index is root 2. How do you know? We found this from the previous question. If the side AC of the above prism is now surrounded by a liquid. So the previous question, we found the refractive index, and the same prism continues in this particular situation also. Now what happens? My critical angle, okay, which is the incident angle at which I strike, where I can see grazing, this will be given by 1 upon refractive index of the first medium, right, divided by 2 by root 3, which is root 3 by 2 root 2. Okay. So if you solve this, the critical angle will come out to be around sine C is equal to something, and C will come out to be 38 degrees. I had seen the sine table, therefore I know the value, which means the critical angle for the two mediums, which is this and this, comes out to be 38 degrees. And what is the angle at which we are striking the ray? We are still striking the ray at 45 degrees. My incident angle has not undergone any change. You can see that for yourself, right? So the critical angle has not undergone any change. I am striking at 45 degrees, right? And my critical angle is 38 degrees. What does it tell you? That your angle is less than 38 degrees, right? With the 45 degree, which means your angle is less than the critical angle, is more than the critical angle. I'm sorry. So the angle at which you're striking is 45 degree. That's your angle of incidence. The critical angle is 38 degrees. So if you go beyond the critical angle, what happens? Total internal reflection, which means the angle of incidence becomes equal to the angle of reflection. Look at this. Okay, so your situation looks like this. You have reflected at 45 degrees. You came at 45 degree, you will get reflected because you have exceeded the critical angle. Whenever you are incident at an angle which is greater than the critical angle, you are going to get total internal reflection. So my answer is total internal reflection will happen. Had the angle of critical angle, which I found out to be 38 degree, been 72 degree, then what happens? If you go beyond had it been 36 degree, okay, which is less than the 38 degree, then total internal reflection will not happen because you have still not attained the critical angle. Refraction will happen at 36 degree, which is smaller than critical angle. Refraction will happen at 38 degree. Grazing will happen. Any angle beyond 38 degree, like a 45 degree angle here, will result in total internal reflection. So I hope your concept is clear in your mind. Be very careful. Total internal reflection is not an absolute thing. It depends on the second medium. So the critical angle changes if the medium here and medium here change. It is not like in the previous question, the critical angle was between glass and air. Here it is glass and liquid. The critical angle needs to change. So therefore, whenever you solve these questions, please be very careful that if there is a change in medium, critical angle will change. You will need to decide whether or not the total internal reflection will happen based on the new critical angle. Your angle of incidence in this question remained same. Okay, so I hope you like this video. Watch this. Please go and watch my playlist of ray optics, and you will see some amazing videos which are very exam oriented, very conceptual, help you retain the concept with a lot of clarity. This is the only channel, I'm again repeating, which is giving you explanation. I'm not solving the problem like whatever junk is available on the internet. These are genuinely made videos with a lot of intent to benefit you. So take that benefit, spread the word about this channel, and give it to your friends so that they also can benefit out of this. You can score a very good rank in NEET examination, JEE Mains, AP Physics, IB Board, Cambridge, Edexcel, Pearson, just by watching my videos. And that should be sufficient. So I keep on bringing a lot of problem solving, a lot of concept oriented questions. Also, don't forget to join my community. I am putting thousands of questions of physics so that you can practice the concepts. The questions are put in a manner that you are able to grasp the topic forever. The retention of the concept will be very strong. So thank you very much for your time today, and I look forward to see you in my next video. Thank you.